We can find relative mins and maxes with piecewise functions also, just have to be a little bit more careful. We do want to start with the same process. We're going to find the derivative, but the derivative is also going to be piecewise. So the derivative, I'm just going to use the power rule. So the derivative here is going to be 2, because that's going to be the slope. Now, as long as x is less than or equal to negative 1, the derivative should be 2. Now, as long as x is greater than negative 1, the derivative is going to be 2x. Now, there is an element that even though the pieces should be the same, we don't know exactly what's going on with the derivative at x equals negative 1. So for right now, I'm going to leave this as not including negative 1. And we're going to see, and I may go back and decide that this can be or equal to, but we have to do a little bit more analysis before we can definitively state that the slope is going to be 2 when x is negative 1. So remember, we're trying to find critical numbers in order to determine potential maxes and mins. Critical numbers are where the derivative is equal to 0 or undefined. So the same thing's going to happen. We're going to look for the 0. And when I look here, this 2 is never going to be 0 no matter what. So this is always going to be a value of 2. This is the only piece of this function that could possibly give me a slope of 0. So when x is 0, I have a potential max and min. So this looks like it's going to be a critical number. Now you do want to double check that this x equals 0 occurs on this rule. So is 0 greater than negative 1? It is. So I do feel like I'm going to be able to include that in my list of potential maxes and mins or in my derivative sign chart. Now the other thing that we want to consider is the undefined. And this is where it gets a little tricky. Remember, undefined, we must consider where the rule changes. If I just look at each piece separately, well, 2 is never undefined and 2x is never undefined, no matter what I plug in for x. But when x is negative 1, I could be dealing with a sharp turn. So I want to include x equals negative 1 in order to determine what's happening. And also, if I plug in a negative 1 here, I can tell that the slope is going to be negative 2. And obviously, if I go right up to negative 1, the slope's going to be 2 on the left side. So I do know that the slope on both the left and the right side are not approaching the same number. So that's how I know this one is also a critical number. Now, I would consider this probably anyway, just mentally, but I can confirm that by doing a little more analysis over here. So now I'm going to do my derivative sign chart. So I'm just going to list my critical numbers real quick. So my critical numbers are going to be x equals 0 and x equals negative 1. Those are the only two that I have. So my derivative sign chart, some of you guys are not labeling, by the way. So make sure that you always label, especially when we start working with second derivatives. It's going to make this a whole lot easier. And remember, this is just an organizational tool. So I'm supposed to be plugging in a number to the left of negative 1 into the derivative. And the question usually ends up happening, kids want to ask, well, where do I plug it in? Well, when x is less than negative 1, I'm going to use this rule. When x is greater than negative 1, I'm going to use this rule. Now, there is no x value to plug in, so I know that on the left side of negative 1, my derivative is always going to be positive. In fact, it's always going to be 2, right? Which means f is increasing. And again, I probably want to go in and write that f prime is undefined here. F prime was equal to 0 there. Now I'm going to plug in a value between negative 1 and 0. So again, I'm going here. So I'm plugging in a negative value. That should give me a negative slope. 2 times a negative number, right? And then I plug in a positive value. 1, 2, 7, 100, as long as it's to the right of 0. Plug that in here as well, because those are the numbers that are greater than negative 1. And now I'm going positive here. So there's my f is increasing, then decreasing, then increasing. So let me make my statements. All right, so where is f increasing? From negative infinity to negative 1, and then 0 to infinity. because f prime is greater than 0. F decreases just from -1 to 0, nothing else happening, because f prime is less than 0. And now let's look for maxes and mins. I can tell that my relative max is going to occur at -1. I should have some sort of sharp turn happening here, but definitely a max because the derivative is going from positive to negative. I have a minimum here because the derivative is going from negative to positive. So we're going to say that we have a relative maximum at x equals -1. If I want to know exactly what that value is, it happens to be where the rule changes, but I would plug that back into the original. So 2 times -1 plus 1. So the point is going to be -1, -1. And we're going to use the first derivative test and say because f prime changes from positive to negative. Some of you have already asked me about if you can use signs, and the answer is no, right? You cannot do this. Okay, that will not work. That will not give you credit. It won't give you credit on the AP exam, and it won't give you credit in this class. All right, we're going to do relative min at x equals 0. Again, plugging in a 0 into the original. 0 is going to be right here, where x is greater than -1. So if I plug in a 0 here, I'm going to get -2 for my value. So that's the point, because f prime changes from negative to positive. So piecewise did work a little bit differently. We had a few little wrinkles in there that we had to pay attention to. But let's make sure we kind of have an idea of what the graph is going to look like. This is kind of interesting. Interesting graph. So I like to plot the points that I know first. So I'm going to plot the point -1, -1. Let me see if I can get a decent scale here. So -1, -2, -3, 1, 2, 1 right here. So -1, -1. I know that's supposed to be a relative max, according to my information. Also know that 0, -2 is supposed to be a relative min. Now, I do know that this is supposed to increase, and then decrease, and then increase. What's interesting is I know exactly what this looks like because this is a line. So this is not just some function that's increasing. This is going to be linear, and then this is going to be quadratic. Now, just to double check, I do know that this is continuous because when I plug in a -1 on both of these, I end up with a -1. So just to check that, that is another kind of layer that I didn't really look at. But when I graph this, I'm going to have a slope of 2. Right? That's going to be linear, increasing, and then I'm immediately going to go into this quadratic. So that is the shape. So here's your quadratic with a relative minimum at 0, -2, and a relative maximum at -1, -1, just through analysis of the derivative.